Yep, the first two are literally just rewriting them. Please don't overthink them and please don't get them wrong, because I promise it is easy. You're just rewriting. In fact, I put them side by side because number 1, you're rewriting to look like number 5, and number 5, you're rewriting to look like number 1. Okay, so your base is the base for your exponent, 2. So this is the base. This right here is your exponent. So 2 to the 3rd.
Equals 8.
And then this last piece is your answer. That's what it equals. So that is 8. So this is your answer for this one. 2 to the 3rd equals 8. The next set of questions is literally going from that form to logarithmic form. So this is your base of your log. That is your base. So log base 13. This guy right here is what you are taking the log of. Log of 169. And the exponent here, the exponent is your answer. That equals 2. So these are your answers for that one. Okay, so that's all we're doing here. That's all we're doing is we are just rewriting. When it says rewrite, that's all you're doing. You're not solving. You shouldn't tell me like one answer. It should be an equation that like this that is your answer. So then that should help you with the next guy, because honestly, you could just say, well, this equals X, all right? And then you could rewrite him. So then this is your base 2 to the what power equals 1 over 16. And so for something like this, if it's in the denominator, your answer is going to be negative. So you really just have to figure out how many times do you multiply 2 by itself to get to 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 times. You multiply it 4 times to get to 16. So then I know it has to be negative to put it in the denominator. So my X here, or my answer here, is negative 4. So you'll have 2 different types of problems. You'll have compounded a certain number of times a year and then compounded continuously. And so you do have to know these formulas. So your amount that you have is going to be your principal times 1 plus your rate over the number of times that you compound, all raised to the number of times your years. So it says Amy invests $1,966 in a savings account with a fixed annual interest rate of 6%, compounded 4 times per year. What will the account balance be after 4 years? So they want to know what the account balance will be. They've given you the principal of 1966. Your rate in decimal would be 0.06. Number of times per year, they said 4, raised to the 4 times per year at 4 years. And then you just plug that guy in. And so you should get $2,494.83. I do not tell you how to round for these because it's dollars and cents, and you should automatically round to 2 decimal places. So continuous is very similar, except it's, I think easier, right? We have your A equals PE to the RT. So your principal, again, is given to you $7,512. E is a constant that is on your calculator. It's a natural number raised to the rate 0.07 times number of years 10. And so when you go do that one, you should get $14,104.61. All right, so within the logarithm multiplication property, so multiplication goes to addition. That's how you separate it. Division, so that goes to subtraction. And then your power rule becomes your exponent. Backwards. Your exponent. It is a power rule, but as your exponent becomes your coefficient when you are expanding. So if I have something raised to an exponent, it becomes the coefficient in front of that. So let's look at this first one. we have log base 4 of z times this group raised to a power, all right? So oftentimes I will do this. I will do this guy, and I will just say this group raised to the 1/2. So I'll do it like that, all right? Because square root of xy is the same thing as xy to the 1/2. Then I can separate these two groups, since they are multiplied, by addition. So I can say log base 4 of z plus log base 4 of xy to the 1/2. Now each one of these is raised to the 1/2, okay? So another way to think about this last piece is log base 4 of x to the 1/2 y to the 1/2. Because when you have a group raised to a power, each thing within it is raised to the power, right? And so I can actually split those up as well. If I write it like this, I can say log base 4 of z plus log base 4 of x to the 1/2 plus log base 4 of y to the 1/2.
Where do you want to have?
Your square root is to the power of 1/2. So anytime you have a root, it's to the power of that index. All right, and so now my last step is to pull that 1/2 out in front. So plus 1/2 log base 4 of x plus 1/2 log base 4 of y. I want you to just point out, I chose this one for a reason. In your answer key, it has the last two pieces. So it has log base 4 of z, but then it has log base 4 of x over 2. Log base 4 of x of y over 2, all right? That's the same thing. So if you see something with the denominator, it is going to be a fractional coefficient, which we're about to do, and it will go back to a root. That's what will happen to it. So if you see something like the next one we're about to do, that's why. I will take either answer. I will take the 1/2 in front or over 2. But when you're condensing, you must recognize that over 2 means to the 1/2. All right, so that's why I'm pointing out this next one we're about to do. All right, so for this one, the first thing I'm actually going to do is I'm going to rewrite these last two pieces, okay? I'm going to rewrite them. So I'm going to leave this first guy alone. I'm going to say log base 3 of z plus these over 2 means there's a 1/2 in front. 1/2 log base 3 of x plus 1/2 log base 3 of y. All right? Everybody see that? Now I do need to double check. It has to all be the same base. Log base 3, log base 3, log base 3. If it's not, you cannot condense. All right? You can only condense if they have the same base. Your goal is to get it to 1 log in your answer. 1 log in your answer. All right? So this next piece, I see that I have additions and I see that I have coefficients. So I'm going the other direction now, right? So that means that my addition go to multiplication, my subtraction would go to division, and my coefficients would go to exponents, all right, because I'm going the other direction. So I'm going to move those coefficients first. Log base 3 of z plus log base 3 of x to the 1/2 plus log base 3 of y to the 1/2. And then I'm going to change my multiplication. My multiplication, these guys are all multiplied because their logs are adding. So I have log base 3 of z times x to the 1/2 times y to the 1/2. I do want to change those 1/2s. What do you think we want to change those to? Square root, right? And since they're both under the same square root, you can put them both under the same square root.
Like it was in 22.
Just like it was in 22. Log base 3 of z square root of x, y. That should look really familiar. It should look like that guy. Okay? So you need to recognize the form when you see it. Those two are really the same except for their bases. One was a base 4, one was a base 3.